Hello, everybody. Welcome back. And today I'm going to talk to you about how to do literal equations. More specifically, we're going to start our understanding of literal equations with J6, but kind of need to get an idea of what people mean by this literal equations thing. So the first thing I'm going to do is get rid of this. Okay, so literal equations. There you go. Now you're taking notes. Okay, so literal equations, if you look it up in the dictionary or online, you might see several different definitions. The first one you're going to say is that it has letters. It has letters. I guess first we should talk about what exactly do we mean by an equation. Well, as you probably know, an equation has an equal sign. So 2 plus 3 equals 5 is an example of an equation. If you're talking about one that has letters, you'd have something like 2 plus x equals 5, and then maybe you need to figure out what x is. Now, some people on their definitions of literal equations insist that it's more than one letter. So x plus y equals 5. Just, I guess for our purposes, we're just going to kind of go with, it's at least one letter. So the second definition that you might see is that other people insist that literal equations literally means literally. In other words, that the letter stands for a specific thing. So an example of that, whenever you have area is equal to pi times the radius squared, well, A is a letter standing for area, and R is a letter standing for radius. So they actually stand in for a specific thing. That's what sometimes what they mean by literal equations. So a big example of literal equations would be such as in formulas. Formulas like this one right here, area is equal to pi r squared. There's tons of formulas. E equals mc squared. Energy is equal to mass times the speed of light squared. That's that whole famous Einstein thing. So when someone says literal equations, you kind of have to ask them or pick up from context exactly what they're talking about. Are they talking about an equation that just has letters? Or are they talking about an equation that has letters and those letters actually stand for something? Okay. So since we're going to be working with literal equations, let's go ahead and look at what we're going to do with J6. J6 has equations where it has variables on both sides. So let's start with an equation with a variable on just one side. X plus 2 equals 5. Well, you guys know that in order to solve this is a one-step equation. You simply take 2 away from both sides. 2 minus 2 is 0. And 5 minus 2 is 3. So x is equal to 3. If you had or another example would be if you were, say, multiplying. 3 times x is equal to 12. One variable. How do you get the variable by itself? Well, you have to divide that 3 out of there. So you can take 3x divided by 3. And if you divide 3 out of one side, you have to divide 3 out of the other side. So you end up with x is equal to 12 divided by 3, which is 4. And you have the same thing with subtraction. So if you had x minus 4 is equal to 7, well, you would add 4 to both sides. So you would have negative 4 plus 4 is 0, of course. And 7 plus 4 is 11. Does 11 minus 4 equal 7? It does. Does 3 plus 2 equal 5? It does. Does 3 times 4 equal 12? It does. And then probably the most complicated one is whenever we end up with a division problem that we need to undo. So let's say that we have x divided by 4 is equal to 5. Okay. What number divided by 4 is equal to 5? Well, you undo division with multiplication. And what do you multiply by? In order to get rid of a fraction, you multiply by the denominator. So that would be 4. 4 times x over 4, those 4's cancel out. And you would just end up with x. And then we do the same thing over here. 5 times 4, doesn't matter in what order you multiply. And 5 times 4 is 20. Okay, so X should equal 20. Let's check it. 20 divided by 4 equals 5. There you go. So these all have a letter, a variable, but it's always on like one side of the equation.